Hello, welcome to Skyera headquarters, where I am joined today by David Davis of Train Signal fame. We've all heard of David Davis, but many of us have also heard of Radoslav Danilak, who is the CEO of Skyera. Thank you for having us today and to talk about some of the amazing technology you guys have that we have in front of us on the table. And before we get started with questions, I just kind of want to show the audience what we're looking at here because it's really impressive. Many of you have seen things like this. This is an SSD. This is less than a terabyte. But what I have in front of me is something much more impressive. We have a box here that is 44 terabytes before you start doing data decompression, at which point it becomes an 88 terabyte behemoth. But it's not exactly a behemoth. This is a 1U half-size pizza box that you stick in a rack, and it's got a full switch on the back. So I mean, there's a lot of potential use cases for technology like this for companies that need to be nimble and portable, but there's also lots of other use cases we'll talk about during this video. Then we have this box, and we'll move the camera down to look at this box. I won't even try to pick it up because I don't want to risk breaking it.
It's
but this is
sturdy. Don't worry, it's sturdy.
Okay.
But it's heavy.
Oh, it is heavy. Holy cow. This is a box that is 500 terabytes of usable capacity, and then after compression and deduplication, this 1U box sports 2.5 petabytes in this box. So I mean, this is a dream for when it comes to pure data density, and this is all super fast storage. So fast, in fact, that when you look at the back of this box, that each controller has multiple 10 or 16 gig transceiver slots where you can use 10 gig Ethernet or 16 gig fiber channel, and this box puts out so much throughput that even bonding two channels together with 10 gig Ethernet does not enable the full throughput capacity of the box. There's that much potential performance and that much potential capacity for this box. And with all that said, let's talk about this, what led to this, this innovation.
Sure. It started with kind of history from solid state space. About 8 years ago, started company called Sandforce, where the premise was to take Flash and bring it to mainstream enterprise. At that time, Flash SLC-based system had been $10–15 per gigabyte, which was very limited adoption. So the premise of my previous company was that I will enable $4 or $5 per gigabyte MLC or consumer class Flash in enterprise. And it was a successful company. Sandforce, more than 90% of SSD vendors are using chips in SSDs. So even some of our potential competitors, they use the SSD, which was based on my previous technology. However, at that time, the Flash had 10,000 writes, the cheap one Flash. So I needed to improve only 10 times more to replace expensive Flash SLC. So my previous technology, which brought basically adoption of MLC in enterprise, had only 10x improvements, which was sufficient at the time. What I realized that on system level, we can enable even cheaper Flash. Even Flash, which today is in your iPhone at less than 50 cents per gigabyte. However, that Flash, you can write only 1,000 to 2,000 times to it. So I needed to come with technology which has 100 times improvements, enabling 50 cents per gigabyte Flash. What I realized that if you don't have system control, if you are just SSD, you cannot do many things to push it to 100x. Just not possible. So my conclusion was to really bring it to mainstream at same cost as disk-based storage systems, I need to enable 50 and 40 cents per gigabyte Flash, and for that I have to build systems. So naturally, smartest guys put brains together, and we founded the Skyera about 4 years ago and decided to build system at price parity with disk-based storage systems without any gimmicks.
Really amazing. So just talk a little bit about what's inside this box here.
Sure. So like if we remove the bezel, what we can see, they are hot swappable fans. They are, back-to-back fans. So if any fan basically stop functioning, we still get airflow. So that's consume of that much space. We will come back to that unit. Here in the back, we have two power supplies, which are hot swappable. That basically, which are consuming this side of the box. And then we have two active controllers with the CPUs and 16 gig ports, which can be either 16 gigabit fiber channel, 10 gigabit Ethernet. So this side of the box is control side. There is no storage here. It's just the processing IOs. So all the more than 500 terabytes, because we need some capacity reserved for RAID and others. So we have way more than 500 terabytes resides in only that portion. So, which that would mean, building in conventional way using SSD, there will be no way of sticking 600 to 700 of these puppies into that space. So, drawing on experience from the past, we design own flash controller and we design own modules. We don't use SSD. We are basically a company which doesn't use the SSDs. We build own modules and with much higher density than SSDs. And that's what is giving us this huge capability. The capability of vertically integrated vendors. Buying the flash, building on modules, building on controllers, building on your hardware and software to create one simple integrated solution.
It seems like just an incredible engineering feat. I mean, being able to fit, 600, the capacity of 600 flash drives inside, this one box here. So could you tell us a little bit about some of the use cases?
Sure. What was very interesting when we start talking to our customers and we start shipping some of the boxes was that they are completely new use cases which you never thought about that. I will talk about few of them. So for example, with the smaller box, we have customer in content creation and distribution where they realize that when they are moving the data or the movies between production sites for post-processing is uncompressed. When today they have been using to upload that over the fiber, and it takes long times because the uncompressed movie and 4K and 8K are really big. They realize that they can just copy the data, put it into box and mail by FedEx overnight. It's much more cost effective and faster than uploading that through the fiber. So content creation and distribution, which is transitioning to 8K, basically require bigger and bigger capacity. So if you are going, for example, to Amazon to shoot very beautiful movie in 8K quality, you need to store somewhere, and you can either take conventional systems, which they are 4 half racks, or you can just take into your basically car the device like that. So that's one usage case. Another interesting usage cases are, for example, in oil exploration, energy exploration, because when you are collecting the data, you either fly the plane to collect geodata, or you are on the boat where you are dragging all the sensors and you are collecting data, which will be later on sold to energy exploration companies. Having much higher density allows you to collect more accurate data, which you can sell at the premium. Also, when the boat basically docks, today you have to unload the data from these systems, which takes long time because they are heavy. You will be not unmounting them when they are multiple chassis, 300-400 pounds. You need to move 5,000 pounds. It's easier to unload the data. In this case, you can just go unscrew 4 screws, remove the basically unit, replace with the new unit, and the boat can go on the trip within 30 minutes, which includes refueling. Same things about the plane. The fact that you can remove the storage because it's so small that it's portable and removable, you can change how things are used. Another interesting usage model in different space, which is enterprise space, is I've been talking with the customers from New York where they are running out of data center space. They are buying conventional disk-based storage systems, and they have primary storage. They have, of course, replicate and replicate again offsite. And big pain for him is building new data center. In New York is very difficult with real estate. So the idea of what basically they are exploring and playing around is that, you know, we are banks, we are conservative institution. You know, it will take us sometimes to migrate to that technology. So I'm not changing my primary storage, what I'm using day to day, so because it's proven is reliable. However, the target, the replication target, I can remove all that space and basically replace with one box, which frees my data center, and few $100 million expenditure is delayed by, you know, 2 to 3 years. So the size, weight, and power, SWAP acronym, creates completely new markets. Think about the government operations where, you know, for example, in military, you need to have airlift, you know, container class data center to target destination, as opposed you can mount things into, for example, like Humvee or car. So it changed completely dynamics, what you can do. And that's what we see, that like when mainframe was present and it requires big rooms, and suddenly PCs show up, the PCs was deployed across the completely new space, additional space, and that's what we see with that storage. It's like moving from mainframe, which is locked in the room, to something which you can carry with you. It's like moving from desktop to laptop. Suddenly you can take with you and do things which you could not do before. And today's you know, MacBook Air is as powerful or more than average desktop, and allows you to do things which you could not do before. That's why majority of the laptops today, they are more sold than desktops, because you can do what you cannot do with older technology.
When we look at this box and it has 500 terabytes, it's, first of all, that's still, I'm trying to wrap my head still around that. I mean, there must have been some interesting engineering challenges that had to be overcome. I mean, SSD, I should say, solid state storage has some known issues with regards to you know, wear and things like that.
That's correct.
I mean, some of those have been overcome, but addressed or life extended through things like wear leveling and things like that.
My previous technology has best extension of the lives what I delivered in the past.
Did you do what wear leveling?
The wear leveling is just not increasing your life, it's making sure that you don't have hotspot which fills portion of the flash. Everybody's doing wear leveling. There's no differentiation factor anymore. There's more a lot of goodies which needs to be put on top of that to make the cheap flash work.
Are you able to talk about some of the things that you put in here to make some of the, to overcome,
sure,
to extend the life of the storage in this?
Sure, let's split into two pieces, basically talking about the box and then about extending life of the flash.
Okay.
So one of the challenging aspect is, which, you know, if you are a vendor who is buying SSD, you just buy SSD, you don't need to spend engineering, you don't need to design flash controller. We have to design on flash controller and write whole flash translation layer. So it's the work as much as my previous startup. So that's one significant amount of work. However, when you have that SSD, you plug in into existing system, you use third-party RAID controllers with software. There was another company, you know, Adaptec, LSI. There are startups which become big companies just developing the RAID. And then, you know, you have other startups which they just buy this hardware and they just build a software level layer.
Right.
Now, you see 3 startups in one, which has big challenges. First of all, is a lot of engineering effort, a lot of cost and time. It takes time to build. If you are building 3 times more, 3 different things, 3 startups is one, you need more engineers, you need more money, you need more time. And that's what we achieve. And also it's very difficult to get all that talent, best guys from flash controllers, best guys from, you know, hardware design and so on.
Right.
So what you see here is the best of controller design together with best of mechanical design and thermal, because putting that much flash into that box and you know, having 1 kilowatt of the power is a lot of challenge from airflow and so on. So this different engineering discipline, mechanical engineering, thermal engineering, you know, semiconductor, software, you have this synthesis in one vertically integrated system. So that's big challenge, and it takes time to build 3 times more or 3 things where others are building 1 thing. So now we can maybe transition to discussion how it's possible to make the most advanced NAND flash, you know, the flash which is in your iPhone,
right,
which is not used in enterprise, what it takes to bring that cost into mainstream enterprise, which is very similar than 20 years ago. You had this pesky hard drive, which all the guys who are selling the enterprise disk systems was basically laughing as consumer technology, which will be, nobody got fired for buying like diameter disk.
Right.
And the hard drive, with RAID solved the reliability of the hard drive and create in the process EMC and NetApp and all other companies, and it changed the game. So now the flash, it's same disruptive point where you have technology which is mainstream. 98% of the wafers produced are consumer flash, or I would say commodity flash, most advanced flash. And now you are bringing that power of the volume to the enterprise. That happened in hard drive, and that's what we are doing with the flash.
Very nice.
So,
well, thank you for your time. We will be moving on to our whiteboard session next.